Today I want to show you how to get the pads on your pad controller light up in FL Studio with the Midi-Scripting function. Because this was a point where I struggled for weeks and probably some months. I just started out on Midi-Scripting. I had no idea about programming. I learned it a bit while diving into Midi-Scripting, but then there was always the point, how do I get the lights here lit up? And I thought, like, this is such a essential and small task in my brain. How do I get the lights to light up? Because all the MIDI input stuff, you dive a bit into it and you get some pretty good results after a while. But how do I get the freaking lights lit up? That was such a mysterious thing to me. So I make a video about it now. So you need to open FL Studio and you need to get in the MIDI settings your scripts into your assigned to your MIDI controller, like here. I use the Akai Force here. Yeah, but this method probably works with all Akai controllers and maybe and probably also with controllers from other manufacturers. So you jump into your script and you need to make sure to name it correctly, like said in the tutorial here. And then you need to import the device module from FL Studio, and then the fun begins with RGB lights, as we have here on the Akai. You need to do it via Sysex messages, system exclusive. You maybe have heard of it. Yeah, that is not the easiest part, not the most straightforward, but here we are. There's a pretty good blog I found on the internet. Someone who decoded the Akai Fire, the FL Studio MIDI controller that failed a bit, but he decoded it a bit and gave a step-by-step tutorial on how to write the Sysex messages. So you need to do it in a byte array, like we do it here. And the byte array, in this case with my Akai Force, it contains 12 slots, and these need to be filled. And like it says here, the first one is always the F0, so that the device knows, okay, now a Sysex message is coming, and at the end you need to write the F7 so that it knows, okay, the Sysex system exclusive message is finished. Then what always comes next on the this is the 0 slot, this is the first slot here, the manufacturer ID. For that you need to go on a site, on a website where you can see these. Here on this website, I link it in the description. There are mostly all of the MIDI device manufacturer worldwide. And so we have Akai right there, Akai Electronics with the 47, but you need to consider or need to see that it is in hexadecimal. So make also sure you write the 0x before all these numbers, so you have it in hexadecimal. The next is the device broadcast ID. And here in that case, in the tutorial, they did a all-call address, and this also works here. This probably is the variable where the communication device to all your connected MIDI devices is set. And so if you have several Akai forces or several controllers from the same type and the same manufacturer, you can specify who will receive the message. But if you have only one connected, like in most cases, you can write the all-call address 0x7f. I don't know if it is specifically to Akai, but maybe this applies also to others. The next one, on the third slot, index number 3, is the product ID. For the Akai force, it's the number 40. On some devices you will find it online or in a reference menu, like here for the Launchpad X, for example. But on most you won't find it. I think I found it also on accident with the Akai force, but there is a thing you can do if you don't know it, because this is crucial. If you have anything here like wrong, this will not work. So as a little workaround, what you can do, you can write a little script where you find it out. So I did here a little loop where you make it like brute force. So you try all out, all possible combinations. Yeah, and each byte can contain the numbers 0 to 255. So you just need to do a for loop with all the numbers, where on the product ID value, the generated value will be inserted, and then you can find out if a pad lights up or not. If it lights up with this, you can decrease the range, and so get step by step to the product ID until you find it. Takes maybe 10 minutes, but this is a way that you can do. And here in this case I wrote a little function. I did this. You need this message right here, the MIDI-out Sysex message, to do it like with the other that I will explain later. But you can do it with the brute force method. Yeah, the next one is the command ID. Is 0x65 is mostly fine because this writes the PadArray. Yeah, most significant bit, least significant bit, 0 and 4 works. Most of this is try and error or look it up, but for the Akai force this works like that. And then comes here the four most important numbers that you will also change when you write a script. You have the slot for the pad number or the light number that you want to do out. Then the for RGB the red value, the green value, and the blue value, and at the end the F7. Yeah, the ending, Sysex ending. And then, like said, you need to create a byte array and assign all the variables after each other. So yeah, but here we don't have the command to to send it out, you also need the command where you insert all this so that it works. If you just have this in your code, nothing will work because you just assigned some variables. And so it makes sense to have a little function where you can that you can use later on to have easy access to turn lights on and off. Yeah, I did this function here where I have the pad number light, pad red, pad green, pad blue input, and here we have the same 4 slots. Here I just repeated them, and so I can assign them here into the slots. And yeah, and then the most important part, we need to have the command to send out a Sysex message. It's device.MidiOut-Sysex, and then very important to put this bytes command here, because it will be sent out as bytes, and then here the array. And then you can write, for example, a little script, for example, with the OnInit. I don't know if you knew it, but there are some indicators or some script events that you can use, and OnInit makes for the tutorial purpose sense because it sends once on the init. Yeah, you probably later on will use on MIDI-Message. And what is also very important is the OnIdle script event. This is like a loop, a constantly loop function, where you can do all your UI stuff. This is pretty important. You can't do all the UI stuff that is possible or that you know from professional controllers without the OnIdle function. And the OnInit function is also important. So you take the OnInit and you write, here we have still our brute force code. Yeah, you can write there for right here. Yeah, like you write your function right there, and you write here your pad number, your R value, your G value, and your blue value. And yeah, and if we execute that, let's click reload, then our first button LED lights up in a kind of yellow way, but we can also say, let's make it, for example, only red. Why doesn't it work? Oh, we need to turn there something in. And now it's red, like you see. And the values are from 0 to 127. Can show you maybe this works, and then we say 0 is nothing, and then we say, for example, 200. That probably won't work then. Yes, like I said, so 128 probably also don't work. Yes, 127 is the highest value that you can put in. So yeah, and what you can do with that, you can write code around it, like with every function, and you can do pretty cool stuff, like if you take this here and then does nothing. Why doesn't it do anything? Oh yeah, because I told it to. So now we have all pads green. yeah, this is a little loop for ranges from 0 to 64. On the fourth, the pad numbers are 0 all the way in line to 64, right there, or maybe 63, I don't know, because it starts at 0. Yeah, this is not on all pad controllers like that, because the input value, let's make it running so we can see the input value is 54 for this pad input, so not 0. That is a bit confusing because a lot of other manufacturers make them equal, the LightOut number and the pad input number, but Akai mostly doesn't do that. So it mostly starts with 0. If they have like a complete pad section, it starts with 0 on the upper left or lower left corner. So that's something you need to consider. Yeah, and yeah, you can also do very beautiful stuff like the thing here. So this is a little color fade that you can do if you do this, and you can get pretty creative. You can do animations, you can do everything. But for animations and stuff like that, you need to use the OnIdle function. Yeah, and now we come to the second part, or to the second kind of lights, because there's not only the Sysex LightOut, there's also a simpler one mostly for the control buttons, like here. As you can see, they are not lit up. Yeah, mostly control buttons have 2 or 3 colors or color modes. Manufacturers keep it simple and do it with MidiOut-Messages, and that looks, you can see it in the API. So if we look here, the MIDI-Out command takes 4 arguments. The first one is the MIDI-ID, the next one is the channel, the third one is data1, which is the pad number, and data2, which is on the if it is an input one, it is the velocity and how do you press it. But in this case, it is the mode of the light. The MIDI-ID is for most control buttons 176, like we can see here. That is mostly the number for that. MIDI channel is most of the time 0, because that's the standard. And then you need to insert the number of the pad or of the button. It makes sense to use a variable for that. So I assigned it here. Step sequencer button is the number 117. That's this one right there. And then we take it to mode number, let's take it to mode number 1. So number 0 is off in most cases, and number 1 lights it up a little bit, 0 turns it off, and here on that, number 2 is red, number 3 is brighter yellow. And number 4, like we all guessed it is brighter red. I think it also has a number 5 mode, which is on orange. And this button has, I think, no further mode. No, it doesn't. So yeah, there you can experiment around. And for what the number 1 or the dim ones are great, they're great if you want to have a standard lighting for them when they are not pressed, when you simply turn the device on so that you can read the writing on the button. And then you can, for example, use mode 3 if you press on it. So so it is shown that you press on that button as visual feedback. This stuff is not it's not pre-programmed. This is you all need to do it yourself, which can be cool. Oh no, which can be cool, or yeah, you have far more freedom. So you can also do like you click this button and this one lights up, or you click this button and everything else lights up, and so you have complete freedom and control about that. Yeah, so FL Studio crashed, but that was it with my tutorial. Thanks for watching. Subscribe for more. Like if you liked it and if you found it helpful, and yeah, leave a comment if you have thoughts about that, if you have a better way, or if you have anything to add to the topic. Thanks for watching.